Hello. I want to do some problems to do with the application of Pythagoras' theorem. And I've got three problems here. One is a ladder against a wall. We're trying to find the length of the ladder. The second is a yacht which sails in a direction north and then due west. And the third one is a person looking up at the top of a tree trying to work out the height of the tree. So the first thing we have to do is to label our diagram with our A, B, C and D. But like I mentioned in the previous video, we have to check that we actually have a 90-degree corner in each one of these, which we do. So the first problem, the 90-degree corner is the top bottom of the wall, so that we can now use our formula. So our sides are going to be, the A is going to be the length of the ladder, the B, I'm going to put that as the side, and C, I'm going to put that as the bottom this time. So I try and decide which one of the formulas I'm going to use, or the setting out. So I'm after the A, so I write down A squared is equal to B squared plus C squared, where my B value is equal to the height of my wall. Now my wall is 4 meters high, so I've got 4 there, and the ground, the distance that I've got is 1.5 meters away from the wall. So my C is equal to 1.5 meters. So there's my two known values. To work out my A, I substitute my B and C in. So I end up with 4 squared. I add that to 1.5 all squared. So on my calculator working that out, that equals 16. And by squaring 1.5, or 1.5 times 1.5, I end up with 2.25 as my answer. Add those together and I get 18.25. Now to finish off the problem, I have to take the square root of both sides. So therefore, A is equal to the square root of 18.25, and that's equal to 4.27. Now of course I have to put my units on the end, so it's going to be meters. So the ladder, to be able to repair that light, needs to be at least 4.27 meters for the person to be able to reach the light to be able to repair it. For the second one is a yacht. A yacht sails due north and then heads towards the west. So the first thing with these types of problems is to write down a diagram, or draw a diagram with the directions labelled on the diagram. So I've put north, I've got south, I've got east, and I've got west. So always start off your diagrams with your directions, so that you know that when you transform it onto the diagram, you'll get it correct. So let's see. First of all, we go due north for 10 kilometres. So my yacht is going to sail this direction. It's going to go 10 kilometres. And then it's going to go due west. So the word due means straight west. So it's going to go straight towards the west. And it's going to go 2 kilometres. Now it's a little bit out of proportion, but we sort of get the idea. Now the question is, how far is it from where they started? So the start is here, and we need to find the distance from where it finished down to our start. So once again, check to see we've got a 90-degree corner. Now where would the 90-degree corner be? 90 degrees is against the north. So I have to label my sides and see what I have to be able to work out my answer. So let's see. Let's call this one A. I'm going to call this one my A. I'm going to call this my B. I'm going to call this one my C. So which one of the formulas do I go with? Well, I'm going to go with A squared is equal to B squared plus C squared. My B is equal to 10 kilometres. My C is equal to 2 kilometres. So I now substitute that in my formula. So I end up with 10 squared plus 2 squared. So I've got 100 plus 4. Add those together, I get 104. So to finish it off, I have to take the square root of both sides. So A is the square root of 104, which comes out to be 10.20 kilometres. Okay, so that's not too hard. That's just using my A squared equals B squared plus C squared formula. The third one is we have to try and find the tree. So we've got a person who's looking up at a tree, and we've got to try and find out what the height of my tree is going to be. The person's 10 metres away from the tree. So we start labelling our diagram with our sides. So the A side is going to be the 40 metres. My B is the side that I'm going to try and find, which is the height. And my C is going to be along the ground. Okay, now where would the 90-degree corner be? Be down for the tree. So there's my 90-degree corner. So I can use my formula. Now in this case here, I'm not after the A, I'm after the B. So if we think back to the previous video, we've got B squared is equal to A squared minus C squared. Now you ask yourself, where did that formula come from? Well, if I take my standard formula for Pythagoras theorem, A squared equals B squared plus C squared, and I take C squared away from both sides of my formula, I'm left with B squared, because these C's cancel out, is equal to A squared minus C squared, which is our formula that we copied down. Now, do you have to show the working out of that formula? No, you can just write the formula down and use it, but you probably need to understand where it actually comes from so that it makes sense. Alright, so what are my values? Well, my A is going to be equal to 40. So the person's line of sight is 40 metres from the top of the tree. But the C value, they're 10 metres away from the base of the tree. So I substitute that into my formula. B squared is equal to A squared, which is 40 squared, minus my 10 squared. 40 times 40 is equal to 1600. Minus my 100, which is equal to 1500. Okay, so we've made it that far. Now what we have to do is to work out the square root of both sides. So therefore B is equal to the square root of 1500, and that works out to be equal to, my calculator, 1500 square root sign 38.729. Now I'm going to round it to 2 decimal places. So I'm going to go 38.73, and of course my unit on the end is going to be equal to metres. So the first 2 problems are using my standard Pythagoras formula, A squared equals B squared plus C squared. And my last formula, my last problem, I have to rearrange it to B squared equals A squared minus C squared, and I substitute my values in, and I get 38.73 metres. Thank you.